I'm Tom DeFanti, and I am also the program chair of this workshop. And I have a dual appointment in that I work here at UCSD for several NSF grants, basically, and including one from CENIC. And then I also work one day a week from CENIC as an advisor to Lewis Fox, who's the head of CENIC. I'm joined by Christopher Bruton, who works 7 days a week for CENIC, I think. And he is an engineer that has been assigned to this project, and we'll get some deep engineering later on. Several people contributed, and you'll see some of these slides over again tomorrow and Thursday from Frank and Larry. The original concept for the Scenic Air was Jerry Sheehan, who was at San Diego State University as CIO. He's now at Salk Institute, but he decided that they were struggling trying to join really the national research platform, and they wanted help from CENIC. And so he came up with this idea of the CENIC CI Commons, Cyber Infrastructure Commons. When Jerry moved over to Salk, I kind of took over the concept and decided that AI resource would be a better term for it, because that's really what we're trying to address. Okay, let's see. There we go. So this is an obligatory slide. What is CENIC? CENIC's a 501c3, in other words, a nonprofit corporation that runs the educational networks in California. Among the the institutes of higher learning here, which are the community colleges, the state university system, privates as they call them, and the University of California system, we're talking about how many people do you think? How many students? Yeah. Yeah. And, the community colleges have 2 million, so actually totally we're approaching 3 million students, which is quite a pile of people. And altogether, if you add the other things here, the public libraries and the K-12 system, it's huge. But the ones we're addressing really right now, although some of the high schools really want to get in on this AI thing with their advanced students, coming to classes for advanced placement, we really want to do that too. Okay, so what's going to go on here is that we're going to do an introduction, and Scenic Air is both for research and instruction. They're the National AI Research Resource, or NAIRR, originally focused only on research. And then about a year ago, about the time of this meeting, we seem to have inspired, I think we had a lot to do with inspiring NSF to add an education component to NAIRR. I decided to do it the other way, just drop a letter and make it pronounceable. So we, Tony Norton back there, who is helping with this project from CENIC's point of view, has said, well, we really need to have describe it to people. How do we do this? And so we decided to do a series of FAQs. Chris is then going to talk about how you connect. So there's two things, if you haven't figured it out by now, with the NRP. One is that pretty much anybody can use it who has a CI logon. And then it's not coupled with also hosting equipment. We love it when people host equipment, whether we buy it or they buy it, because there's power and space and networking that we don't have enough of, even in this building. So there's the hosting stuff and there's the using stuff. I'm going to talk about the using part. Chris is going to talk more about the hosting part. Okay, so just remember a few caveats here. You could read these later, but this is really a research endeavor, an aspirational thing. It's not a product. It doesn't have contracts. It does have some, some acceptable use policies buried somewhere. The things that worry me, though, is not being able to control my buttons here, is that as we become more of an educational and instructional lab usage vehicle, we're going to have to become more of a production quality system, or at least some subsets of us, because people really, if they've got class projects due, they really expect the system to be up. Whereas researchers are a lot more flexible. They understand stuff goes down. Teachers don't. So we got to get serious about that. And a lot of, but we need a lot more support to do that. Okay, I'm going to skip that. But our plan is to become a long-term supported resource. And, in general, there's money in the hopper for 10 years for part of this. So it's not, and then we add other things around it. So CENIC Air is a CENIC connected part of the National Research Platform. It's simply a rebranding. And why do we do that? We did that because I wanted to get CENIC engineering, and CENIC also has this awesome communications group that we have access to. And they are really good. And they get out stuff to all of the people who are on that second page. That's a big deal because I can't do that, And so that's basically our motivation for working with CENIC. Now, there's lots of other reasons, including the fact that CENIC is, currently connects most of the computers that are in the National Research Platform, because it started out as a California thing, which I'll get in there. So there's about 50 institutions now in the National Research Platform. And the core of the National Research Platform is a computer system called Nautilus, right? And it's a big Kubernetes cluster distributed all over the place. So the computers in Nautilus and the network infrastructure that connects them are a resource. And NRP, CENIC Air are programs, basically. So there's a difference between what they are. I want to have plenty of time for questions. By the way, if you have questions, I would like you to interrupt, okay? And I realize in the other sessions, they waited till the end, but Chris and I would rather hear from you when we say something you don't understand or you disagree with, or whatever. Okay, so we started out this project about 8 or 9 years ago because the National Science Foundation, two things had happened. They dumped a huge amount of money into building science DMZs onto campuses, and people weren't using them for anything because they weren't connected. And so Larry Smarr said, let's connect them. Let's write a big grant and connect them. And we got all the University of California CIOs in a line, and they all signed a piece of paper, said, yes, we'll do this. And that was about 8, 9 years ago, 10 years ago, almost. Then a little bit after that, so the whole idea of that thing was to speed up data transfer between the science DMZs. There's the whole idea that ESNet came up with for the science DMZs in the first place. And because we went around measured and, machine to machine, you were getting 5 megabits. And we said, well, we can do better than that. Well, by the time we finished that was called the Pacific Research Platform project, we'd gotten up to 50 gigabits. So 10,000 times improvement. That's not bad, right? Really good. So part of the idea there is well, that's great. We can do all the testing in the world, but we want people to use this thing. And so we decided to start building these Nautilus nodes, which are sometimes from the old days called Fiona for I even forgot what they're called for, what the name was a long time ago. So Flash IO network attachment, I think. Appliance, thank you. I made it up and I forgot. Okay, so I'm really old, So anyway, the idea is to stuff 8 NVIDIA GPUs, and we made them out of game GPUs, because I have actually technically have a 50-year experience in computer games and visualization. And then they sit in racks and make a lot of noise, but they're really they're relatively cheap and really easy to install. And we built them so they'd fit in people's network. Well, most people put their science DMZs right next to their border router. And so these are 2U boxes, or 4U boxes that, you know, we stuck all over the place. And in fact, I put them in my car and drove them there, and John Graham and I installed them. So that was the first part of that. And then last year, we started working with the CSUs. And some of these, Jeff and I drove to places, and other places we just FedExed them. But and then the most recent one, I think, well, actually not the most recent one, but the new concept is working with the community college district. You're going to hear from a bunch of these people at this workshop. So Nautilus is community owned and operated. You know, it's yours. I mean, really. And it's grown. It's got 400 nodes and 1,400 GPUs, and I think it's actually 27,000 CPU cores since I did this slide a few. And Frank claims we've got 15 petabytes of storage, but that should be petabytes. Oh, 7,000 terabytes. Yeah. Should be 15,000 terabytes, 15 petabytes, but some of it you can only get it through the open science grid, so I don't count it. Now, somebody says, in fact, I had a cartoon to throw up here, but I'm not going to confuse my Zoom by trying to do that. A New Yorker this morning came out with a cartoon, and there's people sitting at breakfast table say, oh, look, a Chinese company just gave us another excuse not to be able to avoid hearing about AI. And so, of course, we've all heard about DeepSeek tanking the stock market, among other important things that happened this week. Now, one of the things about DeepSeek is that if you use their servers, your data goes to China. Some people don't like that, right? If you use DeepSeek on our machines in Nautilus, it doesn't go anywhere, stays here. So we, Dima and John and the gang, have been putting up all of these large language models that I have a list here. And they have this DeepSeek thing which runs on one card on a thing called a Qualcomm AI 100 Ultra, which you'll hear more about in the conference. But it's a specific card meant to run, that is, do inferencing for AI, things like these chat GPTs and so on, for large language models. So just want to let you know we're on top of this stuff, you know, and we really get it available right away, and you can use it. Okay, so frequently asked question, does using Nautilus cost me or my institution anything? And the answer is no. It's supported by several NSF awards, and we don't have a method for anybody to pay us. Now, if you want to come over and give me a disk drive or a computer, I'd be happy. And some of you have put in racks of equipment. San Diego State, CSU Fullerton have been fabulous additions this year. But anybody with CI logon can use this thing. And that's the whole NRP, right? All of Nautilus. And you first go to Nautilus nrp.ai, which points you to the National Research Platform.org website, and you join. And that gets you on my mailing list. And then you can use your CI logon credentials. You can make up a namespace for yourself, which is what you call a project in Kubernetes. And then you can have, as an instructor, then you can have your students added on after you've been given admin credentials. We check up on you a little bit before we give you admin credentials. Okay, so how do you get access? You go to the NRP website, pull down the Join Contact Lab, and sign in. And if you know what you're doing and have containerized applications, you can get rolling right away. And then there are also Jupyter Lab examples. And of course, today here, we talked a lot about Jupyter Lab. So this is basically a map that Hunter Headaway at CENIC did. And this shows the various campuses that are actually connected by CENIC and its close allies. This is now showing minority serving institutions. Now, it turns out that almost all the CSUs and most of the University of California now are considered minority serving institutions. We've all been asking each other, today. Shall we supposed to not say that anymore? So we'll find out. And then there's a EPSCoR institutions. EPSCoR states are institutions are ones that are in states get, I don't know, less than, and then the lower tier of people who get NSF funding. And so and the reason we put this in there is because NSF has special funds for augmenting EPSCoR state under certain circumstances, but NSF likes us to have EPSCoR states. And then we have the non-MSI institutions, which are mostly east of the Mississippi, except for, I guess, the University of Missouri is west of the Mississippi, right? If I remember correct. Is that right? Yes. Okay, good. I thought so. Yes, that's right. Okay. So do you have access to CENIC? People have access to other NRP resources, and there are certainly you can get any of the computers. If you were here earlier, they were starting up things and they were being launched in New York and wherever. You don't usually know where your jobs are unless you've got some kind of data distance sensitivity, in which case you want to lock it down. But generally speaking, you don't care. So and that's, of course, what I say there. Now, people also have very successfully supported their software containers to run in commercial clouds, which, of course, costs money, or you have to get, the cloud credits gifted to you somehow, and you will run through them very quickly. But the good part about that is that if you use Nautilus to get your code running, and then you'll probably optimally use your cloud time. If you want to go that way. So we can accommodate thousands of researchers, faculty, and students who have modest data science aspirations, and tens of ones are immodest. I mean, there really is an exponential curve between the heaviest users. Frank and Larry will talk about that on Wednesday, tomorrow. So the only thing that we have trouble meeting everybody's demands for currently are the really expensive high memory GPUs, and because the computer scientists want them all, but they're not what you need to do most of the inferencing, like the National Data Platform access and other things that are that you would use if you were in the an application scientist, using machine learning and artificial intelligence. The Nautilus is actually a very dynamic system. It's not a monolithic thing that when you're done with it, you roll it out to the loading dock and dump it in a trash can. It is very dynamic. It's all over the place. We've got machines that I just this year recently replaced all the 6- and 5-year-old disk drives with new ones. But this is all a very fluid thing. We had resources. People take them offline because they need them for something special, or they drop dead. They're automatically pruned by Kubernetes. It sends this little note and said, "This one's dead. Do something about it, or don't." Kubernetes doesn't care. So every day there's a different number of GPUs and CPUs available. But people are adding to it, and it's growing every day. We do have a model which we actually apply to some of the egregious users, in that they run in background mode. And if we ever get to the point where the utilization is really tight, then we may ask people who don't contribute resources to run in background scavenger mode, because that's fair. So where's the data stored? So we have our own storage. Some of it's in regional Ceph pools. There'll be a lot more discussion about storage, I think, tomorrow. Storage, the problem with storage is forever, and computing is transient, and so it's a different critter, and you have to deal with that. So we don't expect people to use our storage as archival storage, and we don't back it up. And it assumes you can reload your data if needed, and that we will ask you to delete storage if you don't use it, like in a year. that's more pretty much works, except when people ignore it and they're actually shocked when they when we tell them. But the idea is not to fill up all our storage with because you don't want to put it someplace else. There's lots of different storage things that we have dropped. I believe dropped Seaweed FS, doing more with LinStore, and a lot with S3. So again, there'll be more on storage tomorrow. You heard about the National Data Platform. My opinion, with its, it's now 50, I think 5,500 data collections, that this is the most important thing that's sitting on top of the NRP in terms of the wide use in classes in academia and so on, among people who are in the domain sciences, for instance, or social sciences, or arts. Okay, so how does the public cloud relate to Scenic Air? Well, there is a thing called Cloud Bank, which is a way to request resources to be spent at commercial cloud services like AWS or Azure. And you can just look up Cloud Bank. It's part of it's run out of here. And so, that's a way of moving from Scenic Air if you want, or going around. I'm not going to Scenic Air, but you can use Cloud Bank. That's a good thing to do too. Again, it's one of those things where you need to compete. And at Nautilus at this point, you don't need to compete, which is, for a lot of people, especially people starting up who don't have a pile of a long pile of references of already existing research that's been peer reviewed. If you don't have that, it's probably a good idea to go someplace where you don't have to compete. Okay, so we have a thing called Matrix Element, which is our own chat room that we like to use for all communications. Please don't send emails to the engineers, sysadmins. You can send emails to me, but they lurk on this thing all the time. There's a pile of them. You can also set up a channel for yourself if you want, or your teams. We have one dedicated to Jupyter Lab instructors and another to Jupyter Lab admins and operations ones and things like that. So we're trying to create easy buttons for accessing Matrix and Jupyter Lab Hello World examples. Most of our documentation right now is frankly for campus IT support professionals and experienced users. We're writing grants to change that, right? To do much more in the way of making this available to people with more easy buttons and easier things to understand. Okay, so if you want to add resources to Nautilus, your institution has to have a science DMZ. Who knows what a science DMZ is? Okay, so majority of people here. That's good. But knowing what one is and implementing one is two different things. And then even after you've got one, putting a piece of equipment in there and banging through all of the confusions of things going from switches to routers to whatever, and it takes time. And we're, for instance, with a couple of the CSUs, we've got equipment there that's really been hammering on for months, trying to get all little tweaks working. And because remember, the science DMZs are outside the campus firewall, and some campuses just don't want to deal with it. Other campuses are not very good at dealing with it because it's not the way they built their systems. Everybody's a different story. So this, of course, brings CENIC in. And CENIC has developed a bunch of models to help people, some of which are just essentially free advice, and some of them take real equipment. And so Chris is going to come up here and talk to us about those. But none of you have interrupted me. Do you have anything to say? No. Yes.
Now, what's around the ballpark current cost for like a Fiona 8?
Depends on what you put in it. Okay, yeah, the basic cost of the box is $10,000, depending on how much RAM you want to put into it. And of course, RAM thing really jacks the price up. And if you've decided that you want to put a lot of CPU cores in, which we kind of discourage in the GPU boxes, because generally speaking, you offload stuff to the GPUs, and we don't want people using the GPU boxes just for their CPUs. Now, some people have gone out and bought big CPU boxes with no GPUs, and that's great. So then you multiply by 8 the cost of your graphics card, and that can be anything. I mean, it started out when we were doing these things, these graphics cards like $700 a piece, and now they're anything up to $40,000 a piece. The ones that you bought, Jeff, were 5,000, 4,000?
Just under $5,000.
Yeah, so those are A6000s, which are 48 gig cards. NVIDIA has 2 types of cards. They've got gamer cards, and they've got cards that are data center compatible. And for a while, when Bitcoin people were using video game cards, they made them in a way that you could stuff them into these boxes, and which really meant is they reconfigured the fan so they blew out the back instead of out the side. They're called blower cards. You can't buy blower cards anymore. Nobody wants to make them because Bitcoin people don't use GPUs anymore, I guess. So we're struggling with how to get game cards into these boxes, but that's part of our contribution, is to suffer with that stuff. But we do have some new things like these Qualcomm AI 100 cards, which you'll hear a lot about, that service a big piece of that. And they're roughly in the GPU in the game, the high-end game GPU range. Okay, so we're going to turn it over to Chris now. I'm going to turn it over to Chris, and if I can be really clever, I will be able to get up his presentation.